In this presentation, I'm going to go over F-test, testing two population standard deviations. So what is F-test? It's a method used anytime we test two population standard deviations. So how do we set up null and alternative hypothesis for this method? For the two-tail test, the null hypothesis is sigma 1 equal to sigma 2. The alternative hypothesis will be sigma 1 not equal to sigma 2. For the left-tail test, the null hypothesis would be sigma 1 is greater than or equal to sigma 2. An alternative hypothesis would be sigma 1 is less than sigma 2. And for the right tail test, the null hypothesis is sigma 1 less than or equal to sigma 2. An alternative hypothesis will be sigma 1 is greater than sigma 2. What information do we need to perform F-test? We need sample size and sample standard deviation from each sample randomly selected from each population. It is highly recommended to organize them in the form of a table as shown below. So we have sample 1 with the size N1 and a standard deviation S1. And we have sample 2 with size N2 and standard deviation S2. Now, S1 has to be greater than S2. And if it's not, we simply switch the samples. The computed test statistic F is S1 squared divided by S2 squared. As usual, we round to 3 decimal places when needed. The numerator degrees of freedom will be N1 minus 1, and the denominator degrees of freedom will be N2 minus 1. In this example, we want to use the chart below to test the claim that two population standard deviations are the same. Setting up HO and H1, HO will be sigma 1 equal to sigma 2, and that's the claim that they are the same. An alternative hypothesis will be sigma 1 not equal to sigma 2, and that would be obviously two-tail test. There was no significance level given, so we use 0.05. Now let's do the following. We make sure that S1 is greater than S2. We find the CTSF. After the calculation, the CTSF is 4. We find the numerator degrees of freedom, N1 minus 1, the answer is 9. And the denominator degrees of freedom, N2 minus 1, so that would be 11. We're going to draw the F distribution curve and clearly label. We're going to find the right area by using TI command FCDF. And we're going to find the left area using the same TI command FCDF. Why do I need both areas? Since it's a two-tail test, the p-value will be twice the smaller area. So that would be twice of 0.017. So the corresponding p-value for this problem is 0.034. Now p-value is less than the significance level 0.05, therefore HO will be invalid. We have an invalid claim and would reject the claim. If we choose alpha to be 0.03, 0.02, 0.01, then p-value will be greater than the new significance level. Therefore, HO will be valid. That means we now have a valid claim and we fail to reject the claim. Now, how are we going to do this using our calculator TI? We're going to press a stat, go to tests, arrow down to find to sample f-test. So press a stat, go to the tests menu, arrow down to find to sample f-test. We enter the data from the table into sample f-test and then press calculate to execute to sample f-test. So input stats, S1, N1, S2, N2. And since we're doing a two-tail test, sigma 1 not equal to sigma 2, and then we press calculate. The display below shows the results of executing to sample f-test. We have CTS F equal to 4, and we have p-value P in 3 decimals, 0.034. These results confirm our earlier findings. A sample of 15 female students were randomly selected and a standard deviation of their ages was 9 years. In another sample, 10 male students, the standard deviation of their ages was 5 years. We want to use 0.02 level of significance to test the claim that the standard deviation of ages of all female students is different from the standard deviation of ages of all male students. We set up HO and H1. The null hypothesis will be that sigma 1 is equal to sigma 2. The alternative hypothesis will be sigma 1 not equal to sigma 2. In other words, they are different. That's the claim, and this will be two-tail test. The significance level this time is given, so alpha is 0.02. Now we're going to organize the information in the table. So for females, the sample size is 15 and the standard deviation is 9. And for the males, the sample size is 10 and the standard deviation is 5. We verify that S1 is greater than S2. We find the computed test statistic using the formula S1 squared divided by S2 squared, and we get 3.24. The numerator degrees of freedom will be 14. The denominator degrees of freedom will be 9. Now we're going to draw F distribution curve and clearly label. Find the right area using FCDF. Find the left area using FCDF. Again, it's a two-tail test, so p-value will be twice of the smaller area, so the p-value here is 0.082. Now p-value is greater than the significance level, therefore H1 is invalid and we reject the claim. We can verify these answers by using the TI command toSample f-test to confirm their accuracy. If we choose alpha to be 0.09 or 0.1, then p-value will be less than the new significance level. Therefore, H1 would be valid and we fail to reject the claim. In this new example, we're going to use the chart below to suggest the significance level alpha to fail to reject the claim that sigma 1 is greater than sigma 2. So we have sample 1 and sample 2. We have sample sizes and we have sample standard deviations. So let's set up HO and H1. HO will be sigma 1 is less than or equal to sigma 2, and H1 will be sigma 1 is greater than sigma 2. This was stated in the problem. The claim is H1, and it's a right tail test. Now we're just going to go ahead and use the TI command toSample f-test to find the p-value. In this process, make sure that sigma 1 is greater than sigma 2 when you are performing the toSample f-test. And the p-value is 0.013. There is no need to multiply this by 2. It's already right tail test. For H1 to be valid, we want p-value to be less than or equal to alpha. So we want alpha to be greater than or equal to 0.013. So we choose alpha to be 0.02, 0.03, 0.04, or same pattern. I hope this presentation helped you understand f-test, how to set up the null and alternative hypothesis, and how to use your calculator to find the CTSF and the corresponding p-value P.